Introduction. Today we will learn statistics. Let's start it. In the class test, how many of you score less than 10 out of 30? Just stand up. How many of you score between 10 and 20? How many of you score between 20 and 30? Okay. So now can anyone tell me that how can we represent all this data? Sir, we can represent all the data by using statistics. Well said, Rahul. Statistics is a science of collection, analyzing and presentation of data. Let us know more about it. In this lesson, you will learn how to interpret and analyze the collected data. Objectives. At the end of this lesson, you will be able to find the mean of grouped and ungrouped data. Find the mean of grouped data using assumed mean method. Find the mean of grouped data using step deviation method. Find the mode of grouped and ungrouped data. Find the median of grouped and ungrouped data. Analyze cumulative frequency distribution. Mean of grouped data. The word data means information in the form of numerical figures or a set of given facts. Mean. It is the average of the numbers. If x1, x2, and so on till xn are the observations with respective frequencies f1, f2, and so on till fn, then the mean x bar of the data is x bar is equal to f1 x1 plus f2 x2 plus so on till plus fn xn by f1 plus f2 plus so on till plus fn. We can write it as x bar is equal to summation from I, which equals 1 to n of product between fi and xi, divided by summation from I equals 1 to n of fi. If class intervals are given, then we find the class mark as class mark equals upper class limit plus lower class limit by 2. For each class interval, we use class mark as xi in the above given formula. Example. Find the mean of the first 10 natural numbers. Solution. Given data is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sum of observations is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 equals 55. Total number of observations equals 10. Mean is equal to sum of observations by total number of observations equals 55 by 10 equals 5.5. Find the mean of the given data. Solution. First, we find the class mark of each class interval by using the formula class mark equals upper class limit plus lower class limit by 2. In the first column, we have written the class interval, and in the second column, we have written the frequency of the respective class interval. The sum of the frequencies is 31. And then we have written the class mark for each class interval and denote them as xi, and then find the product of fi and xi. And finally, we find the mean using the formula x bar equals summation of the product fi and xi divided by summation of fi, which equals 1095 by 31, which is equal to 35. This method of finding mean is known as direct method. Mean of grouped data. Sometimes the product of xi and fi becomes too large that this method becomes quite time-consuming. To get rid from calculations, we opt for assumed mean method. Assumed mean method. The formula of mean for assumed mean method is assumed mean plus summation of the product of fi and di divided by summation of fi, where a is the assumed mean. We assumed the mean from the values of xi. di is equal to xi minus a. Step deviation method. We have another method to get rid from the calculations, that is, step deviation method. The formula of mean for step deviation method is assumed mean plus h multiplied by summation of the product of fi and ui divided by summation of fi, where a is assumed mean. We assumed the mean from the values of xi. H is the class size. ui is equal to xi minus a divided by h. Example. Find the mean of the given data using assumed mean and step deviation method. Solution. First, we find the class mark for each class interval by using the formula. Class mark equals upper class limit plus lower class limit upon 2. Let assumed mean a is equal to 25, h equals 10. In the first column, we have written the class interval, and in the second column, we have written the frequency of the respective class interval. The sum of frequencies is 41. And then we have written the class mark for each class interval and denote them as xi. In the fourth column, we find the deviation from the assumed mean as d. In the fifth column, we find the deviation from the assumed mean divided by the class size as u. In the sixth column, we find the product of f and d, and their sum is minus 40. In the seventh column, we find the product of f and u, and their sum is minus 4. And then we find the mean using assumed mean method by using the formula assumed mean plus summation of the product of fi and di divided by summation of fi. 25 plus minus 40 by 41. 25 minus 0.98. 24.02. After this, we find the mean using step deviation method by using the formula assumed mean plus h multiplied by summation of the product of fi and ui divided by summation of fi. 25 plus minus 4 by 41 multiplied by 10. 25 minus 0.98. 24.02. Mode of grouped data. Mode is simply a number which appears most often. In grouped data, the value of the mode can be found by the formula as given below. L plus F1 minus F0, that is divided by 2F1 minus F0 minus F2 multiplied by H, where L is equal to lower limit of the modal class, H is equal to size of the class interval, assuming all class sizes to be equal. F1 equals frequency of the modal class. F0 is equal to frequency of the class preceding the modal class. F2 is equal to frequency of the class succeeding the modal class. Example. Find the mode of the given data. Solution. Here the highest number in the class frequency is 9, and the class corresponding to this frequency is 30 to 40. So the modal class is 30 to 40. Now, modal class is equal to 30 to 40. Lower limit L of modal class is equal to 30. Class size H is equal to 10. Frequency F1 of the modal class equals 9. Frequency F0 of class preceding the modal class equals 8. Frequency F2 of class succeeding the modal class equals 4. Now, using the formula given below, L plus F1 minus F0, that is divided by 2F1 minus F0 minus F2 multiplied by H, we will find the mode as 30 plus 9 minus 8 by 2 into 9 minus 8 minus 4 into 10 equals 30 plus 10 by 6, which equals 30 plus 1.67 equals 31.67. Cumulative frequency. Cumulative frequency are of two types. A. Less than type. B. More than type. Let us understand it with example. The grouped data is, for marks 0 to 10, number of students are 2. For marks 10 to 20, number of students are 12. For marks 20 to 30, number of students are 22. For marks 30 to 40, number of students are 8. For marks 40 to 50, number of students are 6. Let us construct a cumulative frequency table of less than type for the above data. Here 2 students got the marks between 0 and 10, which means 2 students have marks less than 10. Now 12 students got marks between 10 to 20. So the students who got marks less than 20 are 2 plus 12, that is 14 students. Proceeding in the similar way, we get the following cumulative frequency table. For marks less than 10, number of students are 2. For marks less than 20, number of students are 2 plus 12 equals 14. For marks less than 30, number of students are 14 plus 22, which equals 36. For marks less than 40, number of students are 36 plus 8 equals 44. For marks less than 50, number of students are 44 plus 6 equals 50. The above table is known as cumulative frequency table of less than type. Let us construct a cumulative frequency table of more than type. Let us know the method of calculating cumulative frequency table of more than type for the above data. Here, all students got marks more than or equal to 0. This means 50 students got more than or equal to 0 marks. Since 2 students got less than 10 marks, thus 50 minus 2, that is 48 students got more than or equal to 10 marks. Proceeding in the same way, 48 minus 12 equals 36 students got more than 20 marks. Hence, we get the cumulative frequency distribution table of more than type. For marks more than 0, number of students are 50. For marks more than 10, number of students are 50 minus 2 equals 48. For marks more than 20, number of students are 48 minus 12 equals 36. For marks more than 30, number of students are 36 minus 22, which equals 14. For marks more than 40, number of students are 14 minus 8, which equals 6. The above table is known as cumulative frequency table of more than type. Median of grouped data. The median is the middle number. Median from ungrouped data. Let the number of observation is n. First, arrange the data in ascending order. Now, if n is odd, then the median is n plus 1 by second observation. If n is even, then the median is the average of n by 2th n plus 1 by 2th observations. Median from grouped data. First, we find the median class. For this, we find the cumulative frequencies of all the classes and n by 2. We now locate the class whose cumulative frequency is greater than and nearest to n by 2. This is called the median class. Following formula is used to calculate the median. L plus n by 2 minus CF, that is divided by F and multiplied by H, where L is equal to lower limit of median class, n equals number of observations, CF equals cumulative frequency of class preceding the median class, F equals frequency of median class, H equals class size assuming class size to be equal. Empirical relationship between mean, median and mode. 3 median is equal to mode plus 2 mean. Example. Find the median of the values 5, 7, 10, 20, 16, 12. Solution. Arrange the data in ascending order as 5, 7, 10, 12, 16, 20. The number of observation is even, that is 6. So, the median is the average of the n by 2th and n by 2 plus 1th observation. N by 2th observation is 6 by 2th, that is, third equals 10. N by 2 plus 1th observation is 6 by 2 plus 1th, that is, fourth equals 12. Median is equal to third observation plus fourth observation by 2, which equals 10 plus 12 by 2 equals 11. Find the median of the given data. Solution. Firstly, we will write the wages of workers and the number of workers. The total number of worker is 100. Here the number of observations n is equal to 100. This is an even number, so the median is average of n by 2th and n by 2 plus 1th observations. That is average of 100 by 2th and 100 by 2 plus 1th observation. That is average of 50th and 51st observations. To find these observations, let us arrange the data in the following manner. In this, we have written the total number of workers who are taking wage up to 3800, up to 4100, up to 4400, up to 4900, up to 5200, up to 5500, up to 6000. The frequencies arranged in above manner are known as cumulative frequencies. The table shown tells you how to calculate cumulative frequency column quickly. So, the fifth observation is 4400 and 51st observation is 4900. Median is equal to 4400 plus 4900 by 2. Median equals 9300 upon 2. Median is equal to 4650. This means 50% workers got wages less than rupees 4650 and another 50% got more than rupees 4650. Find the median of the given data. Solution. In the first column, we have written the given wages. We have written the given frequency. The sum of the frequencies is 31. In the third column, we have found the cumulative frequency for each wages by adding the previous frequency in the current frequency. After that, we have found the median, which is 31 plus 1 by 2th by second, that is 16th observation, which equals rupees 91. Here 12th to 23rd, all the observations are rupees 91. So, 16th observation is rupees 91. Find the median of the following grouped data. Solution. In the first column, we've written the given marks. In the second column, we have written the given frequency. In the third column, we have find the cumulative frequency. After that, n by 2 equals 50 by 2, which is 25. So, 20 to 30 is the median class. Now, L is 20, H is 10, CF is 14, F is 22. And then we calculate the median using the formula given below. L plus n by 2 minus CF, that is divided by F and multiplied by H. Median equals 20 plus 25 minus 14 by 22 into 10. 20 plus 11 by 22 into 10. Median is equal to 20 plus 5, which equals 25. This means 50% of the students got less than 25 marks and other 50% got more than 25 marks. Graphical representation of cumulative frequency distribution. In this, we plot a graph with upper limits of the class intervals on the horizontal axis and their corresponding cumulative frequency on the vertical axis. And the curve we get is called a cumulative frequency curve or an ogive of less than type. If we plot the lower limits on the x-axis and their corresponding cumulative frequency on the vertical axis, then we get a curve which is called a cumulative frequency curve, an ogive of more than type. Note: we can find the median by plotting both the curve on the same axis and the point where they intersect. From that point, we draw a perpendicular to the x-axis, and the point where it meets with x-axis gives us the median. Example: find the median of the given data. Find 1. How many students solved the puzzle? Within 12 seconds. In more than 18 seconds. 2. The time by which 28 students had solved the puzzle. Solution. 1. Draw a vertical line for x as 12 to intersect the cumulative frequency curve. Now draw a line to meet the cumulative frequency axis. The value obtained is 15. 15 students solved the puzzle within 12 seconds. 2. The line at x as 18 seconds gives a value of 26. This means that 32 minus 26 equals 6 students took longer than 18 seconds to solve the puzzle. Draw a line from the cumulative frequency value of 28 to intersect the curve. Now draw a vertical line to meet the x-axis at the point x as 20. This is the time by which 28 students solved the puzzle. So, 28 students solved the puzzle within 20 seconds. Did you know? Statistics is usually considered to be a distinct mathematical science rather than a branch of mathematics. The earliest writing on statistics was found in a 9th century book entitled Manuscript on Deciphering Cryptographic Messages. Summary. Let us summarize what we have learned. The mean x bar of the data is x bar equals f1 x1 plus f2 x2 plus so on plus fn xn by f1 plus f2 plus and so on till plus fn. Class mark equals upper class limit plus lower class limit upon 2. The formula of mean for assumed mean method is assumed mean plus summation of the product of fi and di divided by summation of fi, where di is equal to xi minus a. A is assumed mean. The formula of mean for step deviation method is assumed mean plus h multiplied by summation of the product of fi and ui divided by summation of fi, where h is the class size, equals xi minus a divided by h. In grouped data, the value of the mode can be found by the formula as given. L plus f1 minus f0, that is divided by 2f1 minus f0 minus f2 multiplied by h, where L is equal to lower limit of the modal class, h equals size of the class interval, assuming all class sizes to be equal. f1 equals frequency of the modal class, f0 equals frequency of the class preceding the modal class, f2 equals frequency of the class succeeding the modal class. Median from grouped data. L plus n by 2 minus Cf, that is divided by f and multiplied by h, where L is equal to lower limit of median class, n is equal to number of observations, Cf is equal to cumulative frequency of class preceding the median class, f is equal to frequency of median class, h equals class size assuming class size to be equal. Empirical relationship between mean, median and mode. 3 median equals mode plus 2 mean.